Day 2, problem 1. This problem has two parts, a part A and a part B. And in part A it says, identify the slope and the y-intercept for the graph of, and then we have this equation, y equals 2/3 x plus 1. And once we know the value of the slope and y-intercept, then we'll be in a position to do part B, which is to graph the equation. We're going to use those values that we discover to help us determine how the line of this equation looks on the grid. Maybe the line, looks like this as an example. So part A, we need to find the slope of this equation, that is its rate of change. How is the value of y changing as the value of x changes by 1 unit? Now, when we worked on this warm-up last time, we discovered something very helpful. When an equation is in this format, the letter y is alone, then the equals, then there's the x term. On the very end, there's some sort of constant number. We discovered that the number that's being multiplied in front of x is the slope. And so in this problem, really without doing any work, we can discover that the slope is 2/3, the number that is being multiplied directly in front of the variable x. Now, it's important to realize that is only the case when the linear equation is in this form, where the letter y is alone, and then following the equals is the x term, and following that is the constant term. Now, also when we worked on the warm-up last time, we discovered that the constant number, the number here on the end, is the y-intercept. So again, without really doing any work, we can get that the y-intercept is equal to the number 1 because of this plus 1 on the end. So the y-intercept is 1. And that tells us some very important information about what the graph of the line for this equation looks like. So in part B, we're going to graph a line that is the visual representation of this equation. Okay, first, let's make use of the y-intercept, which we know is equal to 1. Now, the y-intercept of any line is a dot. It will be on the y-axis, which is this line running right down the middle of the grid. And in our problem, we are told it is at 1. So here's the origin, and 1 unit upwards, this is where 1 is on the y-axis. Let's put a dot here. This is the y-intercept value that we figured out for our line. Okay, now the slope, 2/3. Again, slope is another word for rate of change. It tells us how much the value of y is changing when the value of x increases by 1 unit. In this case, y is going to increase by 2/3 of a unit every time x changes by 1 unit. And we can make use of that fact to help us draw a diagonal line. So let's start by pointing at the dot that we've already figured out here at 1 and use the slope to find additional dots. Okay, so when x increases by 1 unit, when we travel 1 unit to the right, the value of y will increase by 2/3 of a unit. So if we had gone up 1 full unit, that would be an increase of 1, or as a fraction, 3/3. Let's not do a full move of 1 unit, but instead go 2/3 of the way up. So, right in the middle is halfway. A little bit might be 1/3, and about right here would be 2/3. So here is another dot. Okay. Now, rate of change continues all the way along a line. It doesn't just happen to get from 1 dot to a second dot, but it can be used to find a 3rd dot, or a 4th dot, or a 5th dot. So we can use this fact again. So starting where we left off, we can go 1 unit to the right, and then 2/3 of a unit upwards. And so getting to here would be 1/3, and then another little bit up would be 2/3. and here's another dot. Okay. Well, with 3 dots that appear to line up, that's certainly enough information to draw a really straight line. We could continue going and get even more dots that line up in a straight line, but let's stop right there and draw our line through the dots. So here is the line. This line is a visual representation of the relationships shown in this linear equation. Now, day 2, problem 2. The table shows how much money Ava has saved. Assume the relationship between the two quantities is linear. Find and interpret the rate of change and initial value. So we're asked for 2 things. First of all, the rate of change. How is the value of y changing as the value of x changes? Or even more specifically, by how much is Ava's money changing each time the value of x, or the number of months, changes by 1 unit or 1 month. And we can determine that value by exploring row to row in the table. Now, it doesn't really matter which rows we look at. For example, we could use the first row and second row of the table to find this. So from the 3rd month to the 4th month, 1 month has gone by. And in that 1 month, Ava's money goes from $200 saved to $225 saved. And we can figure out how much of a change that is. That is a change of $25. And so her rate of change is an increase of $25 in 1 month. Or another way to write that is $25 per month. Now, the next thing that we're asked to figure out is what was the initial value. How much money did Ava have to begin with before she started saving from month to month to month? Now, unfortunately, our table doesn't begin with 0 months. If it did, then whatever the number over in this column is, that would be our initial value. But our table starts giving us information at the 3rd month. However, we can certainly work backwards and figure out, well, what was the value, or how much money did she save in the 2nd month, and how much in the 1st month, and then one more time, how much in the 0th month, which would be her initial value. So let's do that. All right, so for months, what was it in the 2nd month? So now her money. If in the 3rd month of saving, she has saved $200, and we know that the rate of change is increasing $25 per month, we can work backwards and figure out what or how much money she had in the 2nd month. So $200 subtract 25 is $175. After 2 months of saving money, she had $175. And then after that next month, right, after the 3rd month, now she's up to $200, and she continues from there. Now, let's work backwards one more time. What did she have after only 1 month of saving money? So let's begin with $175 and subtract 25. 175 subtract 25 is $150. After 1 month of saving, she had $150. One more time. What about when x is 0? How much money did she have to start with? So let's use 150 and subtract 25, and that is $125. So when x was 0, the value of y is $125, or her initial value we have found is $125.